Physics Lab Course, the Hopper Lab. We'll start with the objectives of this lab, and then we'll review some information that will help you do the lab. Kinematics Equations 1 and 3. We'll briefly mention 2, but we won't need it here. We'll talk about freefall. Then we'll tell you how to do the lab, and how to do the calculations, how to analyze them, and then have a conclusion. Objectives. We will be using an algebraic approach, and we'll determine the time a hopper, and a hopper is one of these guys here, spends in the air, and the initial velocity of the hopper based on measurements of how high the hopper goes. In the stop rocket lab, hopefully you've done that already, or if not, maybe you're going to do it after this, we use the time measurement to calculate the maximum height of the rocket's path. We're going to do the opposite here. We'll measure the maximum height of the hopper's trajectory and use that to calculate the time it spends in the air. That's the cool thing about the kinematics equations. They can be used for many purposes, and depending on what you start with, you can come up with the things you're missing. After the lab, the student should be able to use the kinematics equations and the acceleration due to gravity to calculate the initial velocity and the time that the hopper is in the air. Observe the effect of systematic error in measuring the maximum height. Understand that averaging data is used to reduce the effect of the errors in measurements, and practice manipulating equations and solving for unknown variables. Of course, a large part of physics is mathematics. In the next few sections, we'll talk about the theory that will help you gain these objectives to your students. We'll now review the first and third kinematics equations, how to solve equations, and then talk about the acceleration due to gravity. The three main kinematics equations are right here, and you should teach these before you do the lab. And make sure you emphasize that all three of them require a constant acceleration. The acceleration changes, you can't use these. But fortunately, the only acceleration present in this lab is the acceleration due to gravity, and that is a constant, at least near the surface of the Earth. So we have first one, v is v0 plus at. Second one, x is x0 plus v0t plus 1/2 at squared, and we're really not going to be using that one here. And then the third one, which combines the first two, is v squared is v0 squared plus 2a times the change in distance, or the displacement. And let's see, the big thing about the third one is it does not have time in it, so you can use it when you don't have the variable time.